Hey guys, this is Siri, and I'm back with another PyTorch video. In our last video, we went through an introduction of deep learning. We talked about the three main components of our neural network and what it goes through. We talked a little bit about why it's so much better than what's been there before in machine learning, and we talked a little bit about the training process. Okay, but in this video, we're going to be talking about PyTorch. We're going to be talking about what it is and how it does all of the amazing things that it does and why it's a great choice for deep learning. Okay, so we're going to be talking about PyTorch in this video. Okay, so what is PyTorch, right? What is it? Well, PyTorch is a library. It's a Python library that's mostly used for deep learning applications and or projects. And the neat thing about it is that you can express these complicated things in just like your regular Python code. Okay? And whether it's for a personal project or it's a larger scale application and you're using it in a professional setting, PyTorch is an excellent tool to use. It's an excellent library, and I would definitely recommend it. Many other people would definitely recommend it. And it's a great choice just because it's like overall easy to use nature and for like other reasons too. But it's a really easy thing to learn and to use, and it works really well, and it works very nicely, and it's very slick. And so our deep learning models are very complicated, right? Like we've discussed before, like mapping inputs to outputs and the computation that goes on in between. And to express these computations, like I said before, you can't just pass in your data. For example, you can't just pass in an image just like that. You need to convert it into a form that our model, which is basically a collection of, mathematical functions and optimizers and loss functions and like so many other things going on, but it's mainly math, right? So we need to be dealing with numbers. And so PyTorch offers us a great core data structure called a tensor. And it's a multi-dimensional array, and it's pretty similar to NumPy ND arrays, if you're familiar with NumPy. You can hold numbers, vectors, and matrices and arrays, like multi-dimensional arrays, even higher dimensions than the 0, 1, 2. And you can also perform operations on them. And so this is how our computation actually, executes, right? They're a series of tensor operations and matrix multiplications, and we're just dealing with this whole bunch of data, okay? And what makes PyTorch even more amazing is the fact that you can accelerate your computations. You can make the ginormous number of computations that you need to compute and do, you can accelerate them using a GPU accelerator. Okay, and this can be around 50 times faster than if you did it on your CPU. Okay, and you can also do parallel processing on parallel computing, right, on different processors as well. Okay, PyTorch offers us the ability, it's very flexible in how it presents to us all these amazing features and tools that we can use in our deep learning projects and applications. Okay, another great thing is that you can express your code so elegantly, so cleanly, and it's just nice to look at, You're expressing these complicated things, and you can just write them in, like, I'm not going to say a few because there may be like I mean, it's not like a ginormous amount, but the way it's expressed it's very elegant. Okay. So what did we talk about? We talked about, I'm not done yet. I'm just writing it down here. It's great for personal and professional settings, right? And we have a core data structure called the tensor, right? We can do all our computations on a GPU accelerator. Okay. And express complicated code in clean code, right? Clean and simple code. Okay, so that's what we talked about. And another interesting thing is PyTorch's seamless transition from research to production. So PyTorch, because of its easy to use nature and because of all these things that we've talked about, it's been great for research. Okay, it's been great. And the reason why it could switch so easily to production is that because it's always had a high performance C++ runtime. So you don't need to waste too many resources on Python. And I know we all love Python, right? But it's not as fast as we'd like it to be, especially at this large of a scale when we're dealing with like if we were dealing with images, maybe like tens and thousands of images, right? Once we get to a scale like that, Python's not that fast. Okay, so PyTorch has a great C++ runtime and it helps a lot with performance. Okay, and another thing is that it has bindings to other languages as well, which makes it even more flexible. Okay. And before PyTorch got released, deep learning used to be this massive collection of, data wrappers and, other libraries and other things that you need for actually executing your model, right? So we needed to look all over the place. I mean, they were sort of manageable, but there wasn't one spot where you could look and there wasn't one thing you could count on for everything you needed in this machine learning process. But all that changed, especially since PyTorch's release, probably a few years later. Now, the only two things you mainly see are PyTorch and TensorFlow. Okay, so now you only look in these two places, and you don't need to look all over the place. So that's one great thing that happened after PyTorch's release. And so what this did was it brought a lot more consolidation, and it brought all these different pieces of this deep learning process together, and it consolidated it. So now, PyTorch is the way to go, So, okay, so that's what it does, right? We talked about the C++ runtime. Okay, but how does PyTorch do this? Well, like I said, it has a high C++ runtime, which kind of means that most of PyTorch was written in C++, okay, for higher performance and for the GPU acceleration. Okay, so we're talking about the how now. Okay, how? So that's how. It's written in C++, and most of it is written in C++. Okay, so that allows us to have a higher performance and our GPU acceleration and computation, right? And since the basic building block of PyTorch is the tensor, right? We've talked about the core data structure and the way to store all of this information. There's quite a few operations that we can apply to them, because that's the whole point, right? We apply some computations. We do whatever computations we need to get the output that we want, okay? And so moving these computations from a CPU to a GPU, and a GPU is just like a graphical processing unit. It just makes things go faster, okay? And we mostly use it for games and other things where you need like a lot of like heavy processing going on, right? So, like I said, moving computations from the CPU, so if you have a tensor defined, or if you have some sort of operations that you're doing on the CPU, you can easily move it to the GPU using PyTorch. PyTorch allows you to do that, okay? So moving computations from the CPU to the GPU is a breeze, okay? It's fun. It's just 1 or 2 lines of code, and we'll go through that in another video, but it's easy, okay? Okay, and it's only a function call away, function call or 2 away. Okay, and another interesting thing of the how component is the fact that it keeps track, PyTorch keeps track of the computations, okay, that are done on the tensor. So the tensor, once again, is a multi-dimensional array, and it stores your data in a form that our neural network can understand. Okay, so PyTorch keeps track. I said keep tracks. Okay, keeps track of the computation steps. Okay, and I know we didn't cover this yet, but for our optimization, for our getting better part of this machine learning process, right? You make a few mistakes at the beginning, but then as you move on, as the model iterates through the data a couple of times, or not a couple, but maybe like a lot of times, right? It learns, and we'll talk more about that learning, how it learns, how we're updating parameters, and we'll talk all about all this a little later. But the point that I want to note right now is the fact that it keeps track of the computation steps, and this is important for computing the gradients, which are basically like a collection of derivatives. And we need the derivatives so that we can measure, how the loss is changing. And it's for the optimization step. Okay, so for optimization. Okay, so it's going to be the derivative of the output with respect to the input. Okay, and we'll talk more about that later. There's going to be chain rule involved. But the great thing about PyTorch is that it keeps track of it, so you're able to compute the gradient. And by the way, computing these derivatives for so many different parts of the computation is not difficult, because we have something called dot backward, right? And it can compute the gradient in one step too. Compute the derivatives in just one line. Okay, and that's important for our machine learning. We need to keep track of the derivatives, and because because we need to optimize the parameters. We need to change. We need to see how fast or how slow our loss is changing. And we'll talk more about that later. Okay. But this is the key point here, that it keeps track of the computations. And remember that there are many layers. In PyTorch, we call them modules, which are just these different mathematical functions. Once again, it all boils down to the math, right? And we find these derivatives to optimize our model. Okay. And also, we always start off with data that isn't numbers. I'm gonna bring up the example of images again, right? Our images are not numbers yet, okay? And we need a way to convert our images, or like if we're dealing with text, we need a way to convert that to tensors, okay? And for that conversion process, we're gonna need a dataset class. Okay, we're gonna need a dataset class, and PyTorch offers that to us through the torch.utils.data. Okay, and since this conversion obviously depends on the type of data that you have, right? Whether it's text, whether it's images, whether it's video or audio, right? We're gonna need a custom class for that, which is why it's an important part of the machine learning process, like the data set, using the dataset class and writing your own, but following the outline that it gives us. Okay, and also, since this process is often slow, this process of extracting your own data, and the fact that we need to data source this ourselves, like this process is obviously going to be a little slow. So to make things faster, we're going to need some parallel processing. And Python doesn't do that great with that, like I said. But we need multiple processors to load our data into batches, which is just little samples of our data, which is when, like, one tensor holds like multiple samples of data at once. So in order to load this data and in order to be able to do it on multiple processors, we have another class from torch.utils.dataLoader. Okay, and this is going to be the data loader class. Okay, great. So we talked about the dataset class. We talked about the data loader class. And now let's talk about the training loop. We're not going to go into much detail, but actually, we're not going to go into it at all. Let's just say that these steps that I talked about in our deep learning video, like this loss function optimization and whatnot, this is all part of a loop. Okay, so that's the way it goes. And you know how I said that you can also, or maybe I didn't say that, but we can also use multiple GPUs if we wanted. And PyTorch offers us a torch.nn, which stands for neural networks, .parallel, .distributed data parallel, okay, and a torch.distributed submodule, okay, and it's for this purpose, for doing it on multiple GPUs, okay, for our parallel processing, okay. And like once you're done with this training and once you're ready to, deploy this to a larger scale application, you have a few choices. You can do whatever you want, but a few choices are to export, to, load to the cloud engine if you wanted to. Or you could put it on a mobile app and use these predictions that you've got, and put it in a user-friendly sort of way, in a mobile app if you wanted. Or you could put it on a server for like a larger scale application. And if you wanted to like merge it as a part of, a bigger thing. Okay. And an interesting thing to note is that when PyTorch executes your Python code, whenever something gets executed by the Python interpreter, anything that deals with PyTorch, right? Not just regular Python, but like stuff that deals with PyTorch, they're getting simultaneously executed in C++ or CUDA in the back end, so like behind the scenes. So what this means is that you can compile models ahead of time using something called Torch script. Okay, and if you choose to do this, then you don't need Python at all, right? Like if you can compile the models ahead of time using, C++, you won't need to deal with Python at all in this process. But we'll discuss like deploying using PyTorch in like probably much later, right? Once we get through like the training process and like, first of all, tensors, right? And all that other fun stuff. Okay, so there's going to be a lot of computations that we are going to be dealing with, because we have large matrices and whatnot, right? And we're going to have to do computations on them. But the thing is, pre-trained models work fine on your laptop, and what this means is that like someone else trained it, and we'll talk about pre-trained models in our next video. And even if you wanted to take just a piece of it and like fine-tune it to your own project, you can do that. Like, no, you wouldn't get any super large problems or anything like that. But if you wanted to do a full training cycle and in like a more involved example, you might want to check out like the offerings from like other cloud platforms. Once again, like it'll reduce your computing time by a lot. But right now we're just going to be using Jupyter Notebook so we can run the code interactively and just see what goes on, Okay, so we talked about the how. We have these different classes. So yeah, we have a dataset class that helps us in our conversion process from like the data to the tensor. And it helps with various forms of data, regardless of like whether it's an image or text or whatever. This one helps us with loading it into batches, and we'll see why that's useful, because like it's not necessary to pass in one image at a time. Like you can pass in multiple too, and you can just fine tune that number and like how much you choose to pass into a network at once, depending on the performance and depending on how it does. So this loads it into batches, which are just like a few samples of your data. Okay, and we represent this using tensors, like I said. Okay, maybe this is giving the wrong impression here. So data to tensor, so this is like the conversion. And this helps with, loading our data into batches. We can have multiple GPUs using these modules, submodules that we've talked about. Okay, And we can do all these other fun stuff once we're done with our training. Okay. Yeah, so I think that's all I wanted to talk about in this video. So we've talked about, what PyTorch is, right? It's just a library. It's a library, and honestly, you can just use it for scientific computing if you wanted to, but the most practical application is deep learning. So it's a library, and it's mostly used for deep learning. Okay, so that's what we talked about, you guys. Okay, great. So now that we have just a basic idea of, what is deep learning, what deep learning is, and what PyTorch is, why it's great, why we use it for deep learning, what are the advantages, and how it does it, and we talked a little bit about what goes on after the training, so like deploying it and how Torch script can help us with that, and how we can compile models ahead of time. Okay, so I hope you learned something new today. Thank you so much, and don't forget to like, comment, and subscribe.